All right, everyone. Welcome to our sixth PyData meetup, PyDataTT meetup, I should say. Our speaker today is Mark Moyou, and he'll be talking about design considerations for developing ML-powered search applications. Before Mark begins, I'll just read the code of conduct for PyData session today. So, firstly, just be kind to others, be kind to everyone, and behave professionally. We don't tolerate any harassment, sexist or racist or exclusionary jokes, and foul language are not appropriate for PyData. So just keep it professional. We have a wide range of audience of many different backgrounds. So just continue to operate at a professional level and all will be fine. So, Mark, you can take it away now.
Perfect. Thanks very much. Hi, everyone. Let me get my screen ready to start sharing. Can everyone see presentation mode?
Yes.
Yeah.
Perfect. So appreciate you all inviting me today. My name is Mark Moyou, and currently I'm a senior data scientist at NVIDIA, where I work in the higher education research group more formally. And what that means is I work with some of the top colleges and research institutions across the US on doing scalable machine learning, a little more focused around deep learning now. And ultimately, before I came to NVIDIA, I worked at a enterprise search and recommendations company called LucidWorks, which ran on this search engine called Apache Solar. And that's where a lot of this material for the talk is coming from. And as the title sort of suggests, I wanted to sort of open everyone's vision to this world of search. I think everyone's pretty familiar with recommendations to some degree as you go through your machine learning journey. And hopefully there's some things in here that can help you get closer to production. And just a little bit of flavor, I'm from Trinidad and Tobago originally, and prior to LucidWorks, I worked at a railroad company called Alstom. It's a French billion-dollar railroad company, and I had the opportunity to work sort of as one of the founding data scientists on the North American data science team. And prior to that, I did my PhD in systems engineering, where most of my research was focused on 2D and 3D shape matching. So given a shape of an object, how do you sort of retrieve similar shapes from the database without any text, purely based on the geometry? And, we can definitely get into how you think about machine learning. And the one thing I would encourage you to do as you listen to this talk, even if you're not in the field of search and recommendations, more formally, it's this way of thinking about production systems and how do you take some of these lessons sort of into your own environment. Let's get started. So if you looked at it from three different bullets, as you see here, we're going to look at how is search and recommendations changing, right? Every day, most of us use Google, and I'm sure you'd have noticed, depending on if you're on the end of a beta test, some of the new features that are coming out, and we'll dive into a couple of those. Next, diving a little more into those considerations that you need to keep top of mind as you start to go into production. And what I really like about search is this field that comprises many different subdomains of machine learning. And lastly, we'll talk about this thing called signal data or signals data, and all that is, it's the actual events that, every single thing that someone's doing on your site or on your platform, those are things that you can use to actually get a lot of business value depending on the domain that you're in. At any point, feel free to interrupt with questions. So everything in this presentation has a link to it. So if you see something underlined as I share the slides, they'll actually sort of take you to some external thing to read. And the intention of this presentation was literally to just be like a map. If you're interested in something, take you straight to it so you can learn as quickly as possible. And I like to start with this statement, as this is coming from Google. So as you can read, they are saying that search is not a solved problem. And I think recently I heard an interview with Sundar Pichai, the CEO at Google, where he was saying that search is still their moonshot product, right? And they're still working very hard at it. So in terms of a domain to study and a domain to be involved in, search is is definitely up there, and we'll get into what is search and those types of things. So anytime someone tells you like, hey, search is a solved problem, Google is saying it's not. So that means lots of research to be done. The reason I put this slide here is to remind folks that it's not necessarily about machine learning. It's really about the end user experience, right? What are we doing with all the machine learning that we're doing? And we're trying in search to actually discover more information. So it's not only what you end up going to look for. For instance, if I'm on YouTube, I'll want to discover new and newer things, more new things, so that I can actually stretch my imagination or increase the things that I'm exposed to. So as you think about developing products that retrieve information, thinking about how happy will your users be, and we will talk a bit more about domain boundedness in terms of how you approach a particular problem. I won't be showing any equations or anything in a slide, no code snippets or anything. This is things for you to think about, things for you to go research in terms of what comprises the field of enterprise search and how you actually do information. What are the components that you need to do information retrieval? In terms of domains, I think there's three that are most interesting that I've sort of come across in my prior work history. Top of mind is e-commerce, right? Folks can't visit the store anymore. So how do you actually start getting better search? You can't buy what you can't find. That's the sort of tagline there. If you work within a company, chances are you'll be maybe searching for some documents, and sometimes that search is quite terrible, to be honest. So the advantage that company gets, they become more productive, they save employee time, but it might just be a happiness factor as well. And this is a really great opportunity for, if you're an independent consultant, there are pre-trained language models out there that you can now build pretty good speech to text systems. So if someone has an issue, they can pretty much copy paste the issue or type it in, and you can help them find predefined resolutions a lot faster. And something to think about, if you know folks in different fields that are currently doing some of these jobs, I think machine learning will naturally take over some of these particular facets here, but you always want to make sure that you're involved as well, right? So you stay in front of the field. And here's where it gets very interesting. Different users want different things. And when you go to solve a problem in search, just focus on the content that you have. You might always go back or compare yourself to Google, but Google has to understand the entire domain of knowledge. Chances are, if you work within a company and you're working on a search application, you don't have to search the entire internet. You have to search a very bounded set of documents. So some of the search strategies that you can use will sort of transfer over through different domains.
Sorry, Mark, are you changing slides? Because I'm not seeing them change on mine.
Oh, really? Is that everyone else experiencing that? Oh.
Yeah. I wasn't sure what was happening there, to be honest.
Oh, that's embarrassing. Give me one sec.
That's okay.
Let me end the show and start it again. Let me just share the whole screen so that might. Everyone seeing this? Yeah.
Yeah. I can see this.
Yes.
Okay. This is fine.
Can you see it change now?
Yeah.
Mm-hmm. Yeah.
Okay, so I'll run through it very quickly again, right? So searching a solved problem, it's literally the text there. Hopefully this was a little more eye appealing, at least it appeared to myself while I was watching it. And, we came onto this. And as we head into this journey, just continuously think about how would you match text, right? If someone gave you the job of librarian and they gave you a query, how do you actually go retrieve books or papers and things like that, right? But one thing that's kind of cool that's coming up in search, it's no longer about text, right? It's actually about your preferences and different types of media that will be sort of used. And to be honest, if you are a data scientist in this field of search and recommendations, this is a very, very hot field coming up. So just from a fun perspective, so everyone can see the slides changing, right? I don't want to repeat the same error before.
Yeah, it's
changing. Yeah.
Perfect. And if you just go to archive and you put in searches in the past year for information retrieval and recommendation systems, you can see there are a fair number of sort of papers. I'm not necessarily claiming that all these papers I mentioned this are inherently, full paper on that particular topic, but at least you can see it's fairly top of mind in terms of things that people are thinking about, right? So let's define search. Ultimately, you want to think about how do you say two things are similar, right? And this notion of similarity can be explicitly defined, or it can be learned depending on the approach that you're using. But ultimately, when someone says something is relevant, it's just meaning similar, okay? And naturally, more relevant means more similar, but when you translate that to some vector space distance, given whatever vector-based representations that you have, shorter distance means that you're more similar, right? So sometimes that may be confusing initially when you think about it, but hopefully it makes sense. And this notion of content similarity, what I'm trying to say here, it's no longer about the text, as I mentioned before, right? So if you look at maybe how Amazon and stuff starts to do recommendations, they go beyond looking at the text. They also go beyond looking at the interactions that you have as someone on their platform, right? And we'll get a bit more into that. Let's take a look at like a search applications. When you go on Amazon, I think in terms of the best product search, Amazon does have the best product search on the planet so far, at least maybe on the Western Hemisphere. And you have your search bar at the top. And on the left, you'll see these things called facets. So if you didn't know what that was called before, now you know. So if you hear like someone saying a facet, that's all of these individual values. So for instance, prime will be a particular field in your search index. Delivery day will be a field. Department will be another field. And each of those products will, have one of those values defined, customer review and whatnot. And next, I highlighted this particular part of the page for curated and sponsored content to remind everyone that no matter what type of machine learning that you do, human override is still very important. And as you can see here, I could type in this thing called podcast mic and get some results, but ultimately those that pay get to the top, right? And that's a theme that occurs in search and advertising. You pay, you get to the top of a particular ranking algorithm, right? So that's the ultimate accuracy. Just pay your money and you get to the top of the search page. So some things to think about here. I think there's a great opportunity that's coming in search engine optimization, and it'll become a little more clear. Everyone seen this recommendations slide? And I might ask a couple of times just to make sure.
Yeah.
Perfect.
Yeah.
So when folks talk about recommendations, I'm not going to beat this one to death. The two things that you really focus on are items for an item and items for user, right? Given a particular item, what are other similar items to it? And given a particular person and their entire context, history, preferences, so on and so forth, what should I recommend them in a particular context at a particular time? And while these two things might seem just simple as one-liners, these are entire industries, right? Where you'll have dozens of data scientists working on items for item, and then there are many different sort of types of those, and we'll see some of those coming up. And in terms of I would say the two main sets of algorithms that everyone would probably come across, collaborative filtering and content-based, right? Collaborative filtering is just saying how are you related to what other people have done, and then content-based has no idea what anyone has really interacted with, but really looking at the metadata that you have to make certain decisions of similarity. Okay, and just for reference, I don't think I put it in the slides. Deep learning is sort of the state of the art when it comes to recommendation systems. So if you're doing like ALS, alternating least squares, your next step is to go to, let's say, wide and deep recommenders, or the deep learning recommender system from Facebook. Lots of folks are using that in production now. What's kind of nice in recommendations, you don't actually query with a query. Like you go to Google, you type in a query, right? In recommendations, you actually query with a whole entire item, something that you've interacted with or the input into a recommendation algorithm might be the sequence of things that you've done in a session, right? So this notion of a query item is quite different to this notion of just a raw text query of a couple of words. I show 3 different types of recommendations from Amazon, and the intention of showing them was for you to think about, how would I actually get this algorithm to recommend these things, right? So on the left, this thing says frequently bought together. My hypothesis is this is coming from purchase signals, meaning I looked at what people have purchased and looked at how many times different things were purchased together, right? And that's how you're able to sort of develop that. And like I was saying, you will have someone or a couple of folks working just on this one particular type of recommendation. Next, this is a little bit of personalization to some degree. That's why I put collaborative filtering and brand filtering. But if you kind of look, it's up to Amazon basics, and they were quite similar to this podcast mic that we were looking at. And then the last one, products related to this item. My hypothesis there is, hey, I think they're actually maybe using some image similarity as well, right? Because if you look at the images, they look fairly similar, right? Some of the mics look kind of similar. You have a boom, you have a pop filter and things like that. So as you spend a lot of time with your data, these are good things for you to intuit in your own approach, in your own thinking, so you can kind of maybe estimate what an algorithm is going to do. Okay, let's see. Perfect. Let's just quickly define signals. And if you go work for any e-commerce team and they're not using this thing that we're going to define called signals, that's a big issue, right? Signals generate billions of dollars a year in terms of their power recommendations, they power really great search, and it's very, very big industry. So every time you use Netflix, anything that you do on that particular application, they're tracking all of that, and they're using that to drive all the different algorithms. And like I'm saying here, any real good search application at scale will have a lot of user-generated data, right? And if you are in one of those teams, something that you'll face in certain regions is data privacy. So an interesting question to always ask yourself is, if my data is used to train a model, but I can't actually extract my particular data from that model, when someone, let's say under GDPR, says, hey, you need to clear and delete all of my data, do I actually need to retrain the model? Because I can't necessarily prove that your particular data is in there, right? So just something to think about. So I make several statements in this entire presentation, and it's really around bringing you back to production. So if you were trying to dominate, let's say, the e-commerce market, having the content of your products is not enough to get really good search and ranking capabilities. And, this is a quite bold statement, but based on some of the experiences that I've had in production, you do create a monopoly, and you'll see why coming up. Basically, signals is equal to training data, right? And this is not only true of Google, this is true of any single site. You might have like a small Shopify site that folks are doing searches on and whatnot, and we'll talk about how you can get some value even from a small number of signals. But here's the real beauty of what's happening in a signal. And I like to use Google as sort of a use case. If you look at Google, they've been around for 20-something years, and they've never changed their website, right? You can only do one thing to some degree, other than maybe scroll through news, is give me a query, give me some information, and then I'll return some results to you. So these are the associations that they're making under the hood, right? Given your query, can I get a click, a cart, a purchase, view, any type of trackable action, can do many, many great things. What's kind of cool is, like, if you have really good signals, you can track someone typed on something and they click back, and you can sort of negate some signals. And this is where it gets super interesting when you start thinking of memes and whatnot. So for instance, like when you go on Jiffy and you type in a query, but then you maybe scroll to the third page and click something, folks will use that to actually make a better association between the query and, let's say, the gift that you're looking at. Here's a question that you should bring up if you're ever on one of these teams. Who owns your queries, right? So for instance, most people go through Google and they get redirected to a site. So basically Google owns the query and they just send you as a user to a particular site, but that particular site, let's say it's maybe say Reddit is a good example. Reddit will just get you as a new user, but they have no context of what you really wanted when you landed on this particular page. So in essence, they have an incomplete data set, and you'll find a lot of companies want to now control that query as well. So if you have a company, encourage them to get better search, because what that enables them to do is people they might not search on Google. Most people will continue to out of habit, but if they start searching on your own website, you get to do some cool stuff. And here's another reason why you want to use signals. It's all about understanding user intent when it comes to search, right? It's no longer just, text matching text and things will be okay. Things have to be personalized. And every single day, people are being trained to expect world-class search, right? So every time you use Google and it gets better, you're subconsciously being trained to expect better search from everything else that you do. So here's a brief history. When you think of search engines, this was one of the Apache Lucene. It was an open source search engine. And I refer to them as lexical based search engines because they look at simple edit distances, how text overlaps with each other. And the data structure that's used is called an inverted index, kind of like what's in the back of a book that you use. And from there, Solar was built on top of Apache Lucene. Elasticsearch came out of that as well, and this thing called MongoDB Atlas Search. So for those of you that use Mongo, there's an option there for you as well. And at scale, most large industries run on Apache Solar, I would say, versus Elasticsearch. Elasticsearch is quite easy to set up, but Apache Solar there's lots of configurations that you can do. So big e-commerce sites will run this under the hood, except not necessarily Google, because they would have created their own sort of frameworks. And this is for everyone doing machine learning. This is the area of opportunity that has come, right? It's no longer lexical-based search engines. It's dense vector search engines. So you take a particular query, you encode it as some vector, you have all of your products or documents or images encoded as vectors, and you're trying to search across some vector space, no longer, in the actual domain of the content that you have. And in terms of dense vector search engines that are out there, Facets and Milvus are two of the main ones, right? Facets is, approximate nearest neighbor. So it's a type of search by segmenting your space to effectively retrieve vectors at scale. And some companies that are working on it, right? Google is the furthest one to pioneer it so far. I think right now, do I have it on a slide? I might have it on a slide coming up, but most of the almost every single English query is run by BERT now at Google, right? So it's no longer their original search algorithm that they started off with. The company that I used to work for, Lucidworks, is there. There's another company called Pinecone. Gina is open source. If you're ever looking for a cool project to contribute to there, I think neural search first. So you'll hear this term called neural search, and all that means is you're using some type of deep learning approach in order to do information retrieval. I'll pause for any questions. Any questions so far, or are we good?
I'm good for now, Mark. I don't know if anyone else has any other questions.
Very good. Interesting.
Great. And I just wanted to maybe define vector search and why you would even consider it, right? So if these lexical-based search engines have been working so well, Google hasn't solved search. Ultimately, to come into the realm of personalization, if I wanted to personalize my results in a lexical-based search approach, for instance, if I was shopping for shoes, right, my preferences, I would now have to encode, let's say if I put in, blue Nike Cortez or something like that, right? Blue is a color, right? So whatever algorithm that's using for search will have to recognize blue as a color. Nike is a brand. Nike Cortez is a particular model. But also, if I wanted to inject some of my preferences, I could have been like, it would have been a size, it would have been a certain style. And in order for me to describe that to a search engine, I would actually have to use maybe English words or in the native tongue that you're using. And in order for the search engine to actually match and give me back those results, that particular text would have had to exist inside of the text itself. So what's kind of nice in the vector-based representation, I can now combine different data modalities into the same representation. And now the game really becomes developing your own similarity function in that new vector space that allows you to sort of personalize the way that search works. Okay. If you're ever looking for good, just sort of books, not necessarily papers, these are some great ones to start if you're super hardcore and you want to get into pure search engines. Lucene is the way to start. Solar is what most companies use, like I said, at production or a very, very large scale, because they have a lot of power to control. And Trey Granger's is a pretty popular guy in search. Relevant search is fantastic if you ever get a job as a search engineer tuning search engines. What was very sort of enlightening for me when I first came onto the field is that when you think of machine learning, the dimensions in a vector are your features, right? And that's how you kind of describe an object with different features or different numbers in that vector. In search, your feature is actually a word. So if I chop the word and I take its prefix, that's like a feature in itself. So you're actually chopping up words, and words are features in regular lexical search versus what you experience in pure machine learning, right? And this is a book on UI type stuff. So now what has happened, folks are using a lot more language models, and inherently the way that I like to remind myself about what language models are really good at is understanding the probability of the next word, because they have a lot of context from the sentences that they've sort of processed. And BERT is the state of the art. Some variant of BERT is in production on Google that they publicly announced. And the main barrier to entry right now for most folks, I would say, doing neural search is scalability, right? So it's not necessarily, can I get really good matching? I think if you have the data, you can get pretty decent results. Also, if you don't have a lot of user signal data, you have to temper your own expectations about how good the similarity that you'll get from some of these algorithms are. Oh, so I did put it in here, and in the announcement last year, right? BERT is now using almost every English search query. I think they just released a new update. And if you're ever looking for a really good paper to understand the history of ranking from like lexical based regular search engines all the way up until BERT and what's coming, this person did a fantastic job. And if you've never gone through this tutorial on a visual guide to BERT, highly recommend it. So like I said, some of the things in here are for you to go explore and for other things to continuously think about. In terms of language models, lots of things came out from BERT, and I think most folks are familiar if you're in the field and didn't want to sort of spend too much time there. But as you think about whatever type of search application that you're going to maybe make, or you're doing some type of retrieval, there are other models out there. It's not only BERT, and you have to consider what performance constraints that you have when it comes to am I running with GPUs at query time? How large is my model? How many different, concurrent requests can I make when it's coming into the model? And naturally, always in search, that's the big barrier to entry for, I don't want to say innovation, but types of models that get deployed is response time, right? So a search pipeline and a complete search pipeline from pre-processing and all those things will typically be around maybe 150 milliseconds, 200 milliseconds at most, but that's a whole pipeline. So your model, if you're a data scientist, you'll have to be maybe under 30 to 50 milliseconds. And that's a lot of time in production, actually. So you're probably closer to the 15, 10, 5. That's the response time that your model has to sort of give. And the more data that you have, the slower that response time will be. So keep those things in mind. Here's a cool chart. A friend of mine called Pratik Bhavsar, I highly recommend you guys give him a follow on LinkedIn and join his Slack group called maxpool.club. And they discuss tons of NLP things there. So if you're ever looking for a nice way to choose a particular NLP model, he did a great job in sort of giving you a guide on how to choose a particular model. So great, we've talked about search engines, we've, lexical search, we talked a bit about signals. That's all of the different interactions, me as a user putting in a query, going to the 100th page because I really want this thing, clicking on something. How do I now, I'm using all of that information to improve a ranking algorithm. But what you see now is this thing called knowledge graphs, as you can sort of read, right? So I'll maybe give you a moment to take that in. But ultimately, the question that you have to ask yourself is, why am I going to force a machine learning algorithm or model to completely relearn everything, right? There's knowledge that's inherent in the world. So can you codify that knowledge and put it into a structure that can be used by some particular algorithm, right? So on this slide, ultimately, what I'm trying to convey here is you're going to see this thing called a knowledge graph be used more and more in the future. And all a knowledge graph is, like I was saying, it's that codification of that knowledge and inherently how entities are related to each other, right? I don't want you to read too much into what type of graph is it using. Just think of relations between entities. So most of you would have interacted with a knowledge graph, and Google was, I would say, one of the first ones to maybe publicly sort of showcase its utility. And ultimately, it'll show you a bunch of different things about that particular entity that it has found, right? But here's kind of where it's used in other places. So on the top left, I think this was from Amazon, right? They use knowledge graph to, I think, streamline some research on some COVID-19 stuff. Airbnb uses to sort of manage a lot of their locations and experiences and stuff like that. So as you think about different types of data structures, but also different ways of presenting information to a user, consider just like a knowledge graph. And just remember, the word knowledge is just like, they're just, well, that's whatever they're storing at that point, and graph is just saying like things are connected, right? Walmart is building this thing called a product knowledge graph. All that means is like, how do all the different products relate? And what's kind of cool is that as a human, you might say that one object is related to another, right? But when you actually train some of these language models, let's say I train a question answering system on signal data, and then you embed your products through it, you'll see an arrangement of products in a vector space if you looked at its visualization. And when a query comes in, it also gets a vector in that vector space, and that's how search occurs. But the item that's closest to you now has a lot more context involved, okay? And lastly, on the bottom right-hand side, you can see this is a paper from Home Depot where they're using ontologies on different types of products to enhance search. And I can safely say, like, knowledge graphs produce hundreds of millions of dollars a year in terms of allowing folks to find things that they want to buy, right? Or they even didn't know they want to buy as well. And if you ever embark on a knowledge graph project, keep it very, very simple because they can become very expensive. It's really a non-trivial exercise to get this thing right at scale. Okay. You may hear of algorithms called learning to rank, and basically what they are is you make a request to a search engine gives you, n items coming back, and your job in a learning to rank algorithm is to reorder that top n into something a little more contextualized, right? So this is kind of how I would say more machine learning search was. This is where machine learning came in right after search engine, and then I sort of reorder those things based on some features. However, if your query had a bunch of misspellings, you would have gotten garbage results from a search engine, so you're reordering garbage, right? So now you'll end up seeing language models handle the first query that comes in because they can inherently, because of some of the tokenization, overcome some misspellings and get a better view of the context. And that search in that vector space is essentially doing a different type of reordering. So, but if you hear learning to rank, that's kind of what it means. Okay, let's hop into, your job is to build this thing, right? And your salary depends on it, mortgage, whatever you want to pay with your money that you work with. And the thing I want you to just walk away with, it's no one cares about the algorithm in production, right? People care about the business results that you can achieve. So really focus on that. That's consideration number one. Some things to keep in mind, what types of data you have available, right? This is probably the most defining factor when it comes to what you choose to do. How fast can you process that data, right? We'll just talk about Spark versus Rapids. I think some areas of opportunity there. What are you going to use when you're training certain algorithms, and some of the outputs of those algorithms, how you actually maybe think about doing retraining in production. So when it comes to types of data, think about, do you have access to the actual search queries that came into your website? All of the other metadata. Something that's kind of cool is that you're seeing people now go to surveys to actually see how people are speaking about their products and incorporating that information back into their index. Do you have text and other types of data? It could be sound, it could be audio, video and whatnot. It's a really tricky one if you're using deep learning based approaches. The length of this sequence does, sort of affect some language models. So there's some interesting text processing strategies where you break up the text into sentences and you're encoding each sentence as a vector inside of your index. It does bloat the size of your index. There's some clustering approaches around that as well. And if you're in e-commerce, you may experience this at scale where a vendor wants his product to be sold, right? And what does it mean to be sold? It means to be found. And some vendors may manipulate some of the information to make your search engine a little more skewed into speaking about products the way that they speak about it. And that gives them an inherent advantage over other similar brands, right? So that makes machine learning a little more difficult when it comes to training some algorithms. Next, if you go to process all of this data and think of this data as a query, a user ID, a query, the item that someone clicked on, item that someone viewed on, and you could, to some degree, maybe think about it as tabular data, and you'll always end up working in a pipeline. You're not going to work on a model. There's a bunch of different pre-processing steps that that data has to go through before it hits the search engine and before it's actually a query comes in, and how that query gets processed before it hits the search engine. Think about the speed requirements. So whatever model you're choosing, if you're detecting misspellings and correcting it, let's say, when a query comes in, or when data is being indexed, you're just checking for misspellings. That has to be very, very quick, depending on how often you update your index. And I think Rapids is an interesting case to think about processing your signal data versus using Spark. Training algorithm wise, this is, I didn't want to put it there, but I put it there just in case, right? You won't use your training cluster on your product cluster for search. Those clusters tend to be quite clean. So you typically have to have a lot of uptime. When it comes to retrieving a vector, so a query comes in, a regular search engine, that query just gets processed, broken up into a bunch of different words, and it goes across the inverted index. Now, when you come into machine learning driven search, you have a query, it comes in, it gets turned into a vector, that vector gets, some inner product or dot product against a bunch of other vectors. And those don't necessarily have to be the same index. You can have both of them sort of running, and that's called hybrid search. Okay. And lastly, I'm trying to say here, it's good to have good UI tagging. So for instance, when someone clicks on a particular product, right, you get as much information around that particular event as possible. That'll help you to filter a lot of the data that you use to train a particular algorithm. Lastly, this is kind of similar to that last point. If you have a bunch of different models in production, you will have to do some score balancing. So for every output, you're going to get maybe some measure of confidence or probability. And now you have to combine all of those different measures in order to give a ranking score for something, right? And keep in mind the scale of those different score values across models. And lastly, when you have a model in production and people are interacting with the things that your model is recommending or giving back or ranking, you want to tag that data accordingly, that, hey, this model produced this particular result. So the next time you do retraining, it's easy to filter. Here's one, I think, for everyone to take away as you sort of approach some of these problems. The machine learning metric is not always important or as important as the business outcome. So for instance, like I was just working with a team and they were saying, Leia, we got 10x speed up, blah, blah, blah. And the business just said, hey, I want to see an increase in CTR or an increase in revenue. Otherwise, like, we don't need this. So those are the things that you'll have to face as you engage with some of these teams. Here's another comment about signal training data. It's super noisy, right? So for instance, imagine you shopping for a shoe, right? There's tons of exploration that you will do, and this is where it's super important for data scientists to not only be data scientists, for data scientists to actually be business owners. When I say business owner, owning the domain that you work in. So if I'm working in e-commerce, I need to put myself into the user behavior of my particular domain, right? So if I'm on a shoe website, how do people who really like shoes search for shoes? And that helps you to actually clean the data a lot better to develop different types of algorithms. However, if you don't have access to signal data, getting hand curated signal data is super expensive. And, unless you have an army of folks to label that data, it's going to be tough. There is an advantage that you have with pre-trained language models, but keep in mind the context of the text over which that was trained, right? It might not necessarily apply to your particular domain. Next, build versus buy. I'll sort of run through this very quickly. Ultimately, it's time to value, right? If you don't have a lot of people, a lot of that expertise on your team, it's better to buy it, quicker to test. You do have to maybe watch out for some vendor lock-in as well, and just make sure that whatever data, you always own your signal data and you don't sort of share that, because if someone else has your signal data, they literally have everything. So that's why Google essentially has that monopoly. And lastly, we're getting very close to the end. What I want to discuss in this last section is, I would say, no matter the scale of search data that you work with, getting to know your users is the most important thing. And the way that you get to know your users is through the query, right? Every time someone puts in a query on your site, they're really telling you what they want. So leverage that information to either generate new products, new blogs, or actually help just refine your search in general. And when you think of search objectively, there is stuff that you have, right? If I think of this bucket of stuff, there is stuff that people want that's oftentimes a little bigger than the bucket that you have. And your job is to, match what you have to what they want, right? It wouldn't always be like a one-to-one match, but as much as possible, showcasing, whatever it is that you have to match what they want. And here's an interesting thing that you can use to buy really good keywords. It's more machine learning driven. And this last piece that I put here, when you start thinking about search engines, yes, there's machine learning, but some of the traditional search approaches are very effective, right? If people would give me the synonyms by just actually typing them, I should just probably use them anyway and include them in my search index. So think of that as you work in information retrieval. What is the vocabulary of the user versus the vocabulary of my content that I'm searching over? And now vocabulary, as you move into the machine learning dominant search time in history, let's say this notion of vocabulary is nuanced, right? So vocabulary is no longer text. It might be all of the different objects that have occurred in the content, right? So, or all of the different sound snippets or different sound features that may have been there. So expand your thinking around what content is. And as you maybe start producing your own content for your blog or YouTube and whatnot, just remember that they're watching all these different types of information to make recommendations and search. So as we get close to the last 3 or 4 slides, we've kind of discussed maybe a bit about what search was before and how it's moving and how machine learning is playing a much bigger part. I think for data scientists, they'll end up becoming the new search or SEO experts because they would best understand how these new language models build this notion of relation given some data. Next, we did look at some considerations that occurred for search and recommendation systems. And lastly, if you, like go on your Shopify site or go on whatever website that you have and look at the search queries, get to know your users, that can take you a long way, even if you don't build an algorithm. So quick extras here. Hopefully by next month, I'll be able to release this paper. It's not necessarily a research paper. It was kind of like this presentation where we put together all of the different things that you would go research when you hop into search. It's kind of like a beginner's guide in search. But what's more important for everyone to keep in mind is that machine learning research is no longer done in isolation as an academic community. It's done a lot by companies and communities. So we'll have some folks there that you should go follow on LinkedIn, communities that you should join, just so that you can get involved. If you're doing model deployment, take a look at Triton Inference Server from NVIDIA, right? There's lots of optimizations that you get there. And model inferencing, TensorRT, after you train a model, doing some quantization on it to actually get some better run times at inference time. And if you're doing recommendations more so at scale, look into NVIDIA Merlin. A lot of the data processing for those types of workloads and inferencing is sort of taken care of there, or at least dramatically accelerated. Yeah, so any questions?